Every line of code you write is a decision. Without version control, you are coding in the dark, vulnerable to every accidental deletion or broken feature. Git transforms your project folder into a time machine by embedding a hidden Git vault. This directory acts as the secure engine that records every evolution of your work. When you commit, you capture a complete snapshot of your project's state. This isn't just a save file. It is a permanent, immutable record of exactly how your code existed at that precise moment. Your commit log functions as a chronological diary of your project's life. It maps every change, providing a clear narrative of how your software grew from a simple idea to a complex system. This history is your safety net. If a bug appears, you simply travel back to a previous snapshot, identify exactly where the logic diverged, and restore your project to a stable state. We begin by configuring your global Git identity. Using the git config command with its global flag ensures these settings apply to every repository on your system. By setting your email address, you provide a unique identifier that Git attaches to every commit you make, which is essential for tracking contributions and maintaining a clear history in collaborative projects. First, we need to configure your Git identity. We'll start by setting the global email address, which will be associated with all your future commits. First, we need to configure your Git identity. We'll start by setting the global email address, which will be associated with all your future commits. First, we need to configure your Git identity. We'll start by setting the global email address, which will be associated with all your future commits. Next, we set the global username. This name will appear alongside your email in the project logs. Establishing a consistent identity early on is a best practice, as it ensures that your work is correctly attributed to you across all your local and remote repositories, making it much easier for teammates to identify who authored specific changes.
Next, we'll set the global username. This ensures that every commit you make is properly attributed to you in the project history.
Next, we'll set the global username. This ensures that every commit you make is properly attributed to you in the project history. Now, we create a new directory and initialize it as a Git repository using git init. This command creates a hidden .git folder, which acts as the engine for version control. It tracks all changes, manages branches, and stores the complete history of your project, effectively turning a standard folder into a powerful workspace for development. With the repository initialized, we move into the new directory using the change directory command. Navigating into the project folder is a necessary step before you can start tracking files, as Git commands are context-aware and operate specifically on the repository located within your current working directory. We create a simple text file by echoing the string hello into file.txt. This file now exists in your working directory, but it is currently untracked by Git. Before Git can monitor its contents or version history, we must explicitly tell it to include this file in the staging area for the next commit. By running git add, we move the file into the staging area. This is a crucial intermediate step in the Git workflow. It allows you to selectively choose which changes to include in your next snapshot, giving you granular control over what gets saved in your project history before you finalize the commit. We now finalize the snapshot with a commit using the -m flag to provide a descriptive message. A commit acts as a permanent record of your project's state at a specific point in time. By including a clear message, you create a meaningful narrative of your development process, which is invaluable for debugging and future collaboration. Finally, we use git log to inspect the repository's history. This command displays a chronological list of all commits, showing the author, date, and the unique hash associated with each change. It is the primary tool for auditing your project's evolution and verifying that your commits were recorded exactly as intended.